This video is going to be the first of two videos on the derivatives of logarithms. Now we're going to start off in this lesson by introducing some basic notation and also look at working in base E. And then we're going to go and look at a formula for the derivative of a log. And then we'll expand on that at the end of the video by introducing the chain rule and how it can simplify differentiating some more complex looking log expressions. Now before we go talk about the derivative, let's go look at some notation. So suppose we have this equation here, y is equal to log base e of x. Now notice this base e that I've given the log. This e is a number a lot like pi, meaning it's constant. It has a fixed value. It's not a variable. Now the value itself we're not going to be concerned with, but really all that matters is you know that whenever you go to differentiate or integrate a logarithm, it has to be in base e. And in fact, in the second video, we'll go ahead and talk about, well, what do we do if we ever find a logarithm not in base e? But for now, we're just going to think of all our logarithms in base e. And because we see this so often, we also get several different ways of expressing the same thing. So sometimes you'll see log x with no base. So if you ever see the base omitted, it's assumed to be in base e. And even shorter still, we have ln x. Okay? So all of these three mean the exact same thing. And we can use any one of them to express log base e of x. Okay, let's talk about the derivative. Now, we don't need to know the proof for this formula, so we'll just state it as follows. If we take the derivative of y with respect to x, or in other words, the derivative of log base e of x, just quickly making sure that we're working in base e, then this will just be equal to 1 over x. So this is the basic derivative. Make sure you know it. Of course, more often than not, we're not going to be differentiating something so simple. So let's go ahead and apply this now, using the chain rule, to something a little bit more complex. Suppose we now have y is equal to log base e of ax plus b, and we want to find the derivative. Well, now we can instantly see that what we have inside the brackets is ax plus b, and that's not equal to x. And in that case, we can't apply our basic formula. And if you remember back to the differentiation laws, whenever that happens, we need to apply the chain rule. So the chain rule goes as follows, that if we take dy over dx, this is equivalent to dy over du times du over dx, where u is some sort of substitution, and the substitution we're going to make is simply we're going to let u equal to ax plus b. So now all that's left to do is work out these two values here. So let's start with dy over du. And to do that, we're going to see that, well, if u is equal to ax plus b, then y is simply equal to log base e of u. And now if we take dy over du, this fits our basic formula up here. So the derivative of y with respect to u is simply going to be 1 over u. So that's one part done. Now to work out du over dx, it's simply a matter of differentiating this substitution step over here. Okay, so we differentiate u with respect to x. The derivative of ax is a, and the derivative of b is 0, so we don't need to include that. So now we have all the parts we need to rewrite our derivative. So the derivative of y with respect to x is now 1 over u times a. And of course we're going to unsubstitute our u back to being an x. We don't want to leave it as u. So we get ax plus b times a, or more simply, a over ax plus b. And what we can see has happened is the term inside the brackets of our logarithm ends up being the term at the bottom of the fraction. And the number that goes on top is simply the derivative of the bottom of the fraction. So if we differentiate ax plus b, we get a, so that goes at the top, and ax plus b is what was originally inside our brackets. And this is the easier way to remember how to differentiate a logarithm. So we don't want to have to use the chain rule over here all the time. It's a very long process, as you can see. So to simplify things down, just remember this. When we take the derivative of a logarithm, we just take what's inside the brackets, put it at the bottom of a fraction, and then we differentiate that to get the top. Okay, so let's do a quick example and see that in practice. Suppose I wanted to differentiate y is equal to log base e of 2x plus 5. Well, without using the chain rule, I now know that dy over dx, first of all, simply has 2x plus 5 as the denominator. Right? The denominator from our log expression comes from the bracket. And then at the numerator, we simply put the derivative of that bracket, which in this case is simply going to be 2. Right? It's the value in front of the x when we have a straight line, and that will be our answer. Right? We don't have to use the chain rule if we know something like this. Now, of course, this does generalize to things outside of straight lines. And in fact, we can prove something similar for a general function. So let's say y is equal to log base e of f of x. So fx here is some function in terms of x. We don't know what it is. And at this point, we don't particularly care. So we need to use the chain rule once again. We know that dy over dx is equal to dy over du times du over dx. Now the substitution we're going to use here is we're going to let u equal to whatever is inside the log brackets, and in this case it's fx, right? So we're going to let u equal f of x. So once again, y is going to equal log base e of u. So y, which means the derivative dy over du is once again going to be 1 over u. Now, as for du over dx, since we don't know what fx is, we're just simply going to write f dash x, so the derivative of whatever fx is. So now we can simplify this once again to saying, well, then dy over dx will be 1 over u times f dash x. And this is the same as 1 over fx. So we're taking the u and substituting fx back into it. 1 over f dash x. And then we end up with this expression here, that dy over dx is equal to f dash of x over f of x. So this is an important result to remember if you don't want to use the chain rule. And it simply goes as follows. When we take the derivative of any log function, we'll just take whatever's inside the brackets as the denominator, exactly as it is, and then we'll differentiate the denominator to get the numerator here. And so let's finish up with one more quick demonstration. So suppose I wanted to differentiate y is equal to log base e of x squared plus 1. Okay, so now if we don't want to use the chain rule, we can use the previous rule as follows. Well, then the derivative dy over dx, first of all, we'll have the function x squared plus 1 at the bottom, right? Remember, it's whatever's inside our log brackets. And then we can just differentiate x squared plus 1, and we know that this should be 2x. So it's 2x over x squared plus 1. So once you get more familiar with logarithms, you can definitely use these sorts of shortcuts to help you differentiate. It's not too much to remember, but if you're still uncomfortable differentiating logarithms, by all means, keep using the chain rule until you get a little bit more familiar.